Nonlinear stabilization and damping can be activated from the Nonlinear Controls box of the Details window of the Analysis Settings branch. In the Nonlinear Controls box, the last tab is Stabilization. There is a list next to the Stabilization that has 3 options. 1. Off. 2. Constant. And 3. Reduce. If the stabilization is set to off, the stabilization and damping will be inactive. If the stabilization is set to constant or reduced, additional inputs will be requested. In the constant option, stabilization energy is kept constant throughout the load step. In the reduced option, the stabilization energy is reduced as the solution progresses through the load step. If we set the stabilization to constant or reduced, 4 parameters will be requested. Those are as follows. 1. Method. 2. Energy dissipation ratio. 3. Activation for the first substep. And 4. Stabilization force limit. Method is by default set to energy. It is recommended to keep it the same. The energy dissipation ratio is by default set to 10⁻⁻⁴. It is the ratio of work done by the damping force to the elemental potential energy. As we have seen in the previous module, elemental potential energy, or stiffness energy, is very high when the deformations in the structure are very high. The damping force will work to reduce the deformations. Energy dissipation due to the damping force can be imagined as the damping force multiplied by the deformations due to the damping force. This ratio of the two is the energy dissipation ratio. When it is set to 1e-4, 0.01% of the elemental potential energy is dissipated due to the damping force. As additional damping forces are added to the structure, accuracy of the simulation is reduced. The reduced accuracy is restricted by the stabilization force limit. By default, it is set to 0.2. It is the ratio of the L2 norm of the damping force to the L2 norm of the reaction forces. This stabilization force limit of 0.2 indicates that the L2 norm of the damping force can be maximum up to 20% of the L2 norm of the reaction forces. Although the stabilization force limit appears high, it is generally activated when the stiffness and force on the structure is almost close to zero. Therefore, in the most cases, stabilization force only marginally affects the overall accuracy of the simulation. However, it is recommended to check and verify the same. The only remaining input request in the stabilization and damping is the activation for the first substep tab. This tab has 3 options. 1. No, this option will not activate the stabilization in the first substep. 2. On non-convergence, this option will activate the stabilization in the first substep only if the solution does not converge. And 3. Yes, this option will activate the stabilization from the first substep